Right. On question 11, the problem asks you to find, if you're given a side of a triangle of 1 centimeter and you have another triangle with 3 times the area, what is the corresponding side length here? So we're looking for this value x. Okay. In a lot of these problems, especially ones that are dealing with similar figures, look to identify what the ratio of parts or areas is. You're going to be given one of those. In this case, it tells us that the second one has an area that's 3 times the first, triple the first. So we can identify the ratio of our areas as 1 to 3. And remember, the ratio of parts is given as m to n. The ratio of areas, we'll take that ratio, and because area is a two-dimensional measurement, it'll square that ratio. And so here we're just moving backwards. So if we needed to move from the ratio of areas back to the ratio of parts, what are we going to need to do to these numbers? Square root them. So we get the square root of 1, which is 1, and the square root of 3. So we can create our dilation factor for individual parts. And you're going to think of this as either 1 over root 3 or root 3 over 1. This is the one if the triangle gets smaller, and this is the one if the triangle gets larger. And so which of these dilation factors are we going to need to use when we move from a small triangle to the larger one? Right here. So all you need to do is take this factor, multiply it by the given value, so root 3 over 1, and that is your solution. So 1 times the square root of 3 over 1 is just the square root of 3. So that would be the length of the corresponding side.